Hey guys, I've been working on the belt drive system for the Precision Matthews. I've got both the motor pulley as well as the spindle pulley completed. It looks like I'm going to be using it's a J-Poly V-belt. It has 6 ribs, and this one is a 190, which is 19 inches long. This will give me about 5 1/4 inches between centers, which is going to work out just right for me because I'm going to be moving the motor back. The motor is going to be moved back because I'm going to have a 4-inch air cylinder sitting on top, and so the center line is really close right here, so I need the space. So the motor is going to have to be pushed back, which I can push back about 2 inches, so it should be okay. In the stock location, they're 4 inches on center, so I'm only going to be moving it back about 1 1/4 inches or so. So I think we'll be good. It's kind of hard to work on the belt drive and be able to use the mill. I had to pull the spindle out. When I did, I noticed, maybe you can see here in the video, see if I can get it. You can see that little hole right there. That is for the guide pin for the R8 collet. That pin backed out and it scored my spindle all the way around pretty deep. It's probably 3/32 deep minimum groove all the way around. So the way this is going to assemble is of course this will be on the motor, and it has this step right here, and that's just a spacer, so it'll bolt like that, and then there'll be a washer and a bolt going through the center of the shaft. These Leeson IEC metric motors are threaded in the center, so that's nice. I'm going to have to try to cut a keyway. That'll be in a future video, and also some more machining on this spindle pulley, and let me show you that. Now, to mount the pulley onto the spindle, originally what my plan was to do was remove this spur gear that has these teeth, because these teeth are critical. This is what grips and makes the spindle turn. Now Gary, a gentleman that converted a RF45 series mill at least 6 or 7 years ago, he had a build thread on this zone, and what he did was he took this piece, which sits inside like this. You can see the top of it there, and what he did was he inverted it, and then he turned all this off right here, these gears, and what he did was he threaded the top of it and then put a castle nut on there. This is a 30mm diameter, and so the pulley would slide down over that, and then the castle nut would screw on there and tighten the pulley. And then he would thread the end of his spindle and put a hat on top to use to pull up for his power drawbar. That was a very clever way of doing it. However, you had to pull this out, turn all this down, and then thread it. It was a lot more work, and there's no way that you could ever convert this back to a manual mill if you so desired. It was well thought out, and I thought that would be the way I would go. Well, about a month ago or so, I saw a gentleman, Nicholas Miller. That's his YouTube name, and you can check out his channel. He's converting a G0602, which is fairly similar in the overall design of the spindle, and he's doing a lot of cool things with his G0704. I said 602, but I meant 704. He's putting linear waves. He's putting a air intensified hydraulic power drawbar. Very neat little setup there, so go check his videos out. But what he did was he just turned the gear off of this and then left it intact. Probably what I'll do is take the mating gear out and just leave this as is. And then with his spindle, he turned it in a fashion so that he could slide this right over. Now this groove right here is for a E-ring or snap ring, I guess. And this one, it's outside, so it's a snap ring. And then you can see there's another one there. But so what this will do is will just slide down over until it bottoms out on this and the clip. And then you can see the clearance here for this raised area. So it'll sit on there something like that. So let me put this all together for you. So this is inside the gearbox here. And then this will go over like so. I'm not sure exactly how much I'm going to have sticking out until I get it all put in there, but at least 3/4 of an inch I would think, maybe a little more. This will be threaded for a top hat, and the top hat will screw down on top of this and hold it down. Now this is just round, so it's just going to turn. So what Nick did was he took 3 steel pins and machined pockets and slid the pins down in there like so. And then that blocks the spindle with the pulley. And these, like I said, they'll be recessed in there. I'll have to machine that out on the Precision Matthews. And then again, the top nut will just screw down on, clamp all that in, and lock it together. Now, this method was real simple. There's a little extra machining on the pulley, but otherwise, it didn't really mess with the integrity of the gearbox. You don't have to turn these threads off. You can just take this mating gear. There's a gear in the gearbox. You can just remove that out and then have everything still basically stock. All my machine builds have been using metric fasteners. I've tried to keep the machine as stock as possible, and then this is just another way that I can still do that and maintain all the stock components. So I think that's the route I'm going to go. Nick, I appreciate the you posting your video and inspiring us to follow. Very clever idea, and I've already spoken to Nick about this and told him that I was going to use this. He said, go ahead, Sam. I just want to share that, and I'll post a link to his channel. Go check it out. He's doing a great job on the G704. So I shot some video earlier machining these out on the G0602. There were quite a few setups. I had a boring operation, actually 2. These are 2 different hole sizes. 2 different turning operations, roughing operations. I had backside and front side turnings. So what I did was I roughed the blanks out first, then I came back and put in the poly V grooves. That was fairly interesting. They match up really pretty good. If I can get it angled right where you can see it, but it matches up pretty good. And then on the small diameter pulley, I could only CNC these last 3. I didn't have tool clearance, and you'll see that in the video, so I had to come back and manually do the last 3. They work pretty good. I don't think they're perfect, but I think they'll work just fine. So let's go out to the G0602 and we'll see some of this machining. Alright, so now we're going to start working on the spindle pulley. I'm going to bore out the center hole to fit over the spindle, and we're going to be doing some relief. Well, now I'm going to work on the V grooves for the small diameter. Now, because of tool clearance, I can only get about 3 of the 6 belts. So I'm going to have to come back and do some manual machining to get the other 3 grooves in there. But I'm going to do what I can with the CNC. So I've got the spindle pulley in there, and before I can finish cutting these ribs, I want to undercut the pulley. See how I've got it stepped? This is to go over the top of the spindle. I'm having to do this manually. Okay, so all we have left now to do is just finish up manually these last 3 grooves. What I'm going to use is just a threading tool. It's not quite the exact shape as the groove. See if I can get a shot here, but it's pretty close. It's pretty close. So it worked well on the other pulleys. So see if you can see this maybe better. Get the angle right. So what I'm going to do is use it. Now, in between each one of the V grooves, the bottom of the V grooves, I'm getting all clumsy here. In between each one of the bottom of the V grooves, the distance between the center of one to the next for the J poly belt, which is what I'm using, is 0.092 thousandths of an inch. So what I did was I'm going to line up dead center of this one, and then I'm going to just back up, jog it over 0.092 and work my way in. And once I get to the required depth, I'm going to just kind of barely jog it over each way just a little bit, just to widen that up, and that should work just fine. Now I finished up recessing the back side of this pulley here, and that is to go over the raised area of the spindle where the gearbox is, on the gearbox cover that you can see in this photo here. So I just manually jogged it in to cut this second one, the third one here. Now what I'm going to do is I'm going to move it over. And then we'll cut the next one. Alright, that's the next one. Gonna move it over another 0.092 to get the last one. Alright, for the last one I have to be careful and go real slow because I'm really close to the side of my cutter, and it builds up with chips, and then it wants to mar the surface here. So it's not a big deal if it gets scratched up, but I just try to be careful, and I think I can alleviate that issue. So we're going to move it over again another 0.092. So that wraps up this video. Stay tuned for the next video. Got a lot more to work on. I've got to machine out these holes to recess these pins. I need to try to figure out how to cut a keyway. It needs to be a 6mm key for the motor. Got to build some risers to raise the motor up. Got to build a motor mount plate for the motor. It'll just be one hole here and another hole here, and it'll be able to just pivot and adjust. Real simple. I don't think it really needs much more than that. Yeah, so a lot more to do. So I guess this will be part 1 on the belt drive. And stay tuned for the rest. If you have any questions or suggestions, please feel free to comment. Stop by and see Nick Miller's YouTube channel and check out his 704. If you're not familiar with Gary, I'll see if I can post a link to his RF45 conversion. It's been on the YouTube a few years, so you guys may have seen it already. Stop by and visit the website if you're interested in plans to convert your Precision Matthews. Thanks for watching. Please subscribe. Thumbs up if you liked the video, and most importantly, be safe.